Hello everyone. Today we are embarking on a cosmic voyage to the most extraordinary exoplanet ever discovered, Proxima Centauri b, the closest potentially habitable world beyond our solar system. For centuries, humanity has stared at the night sky and wondered if we are alone, if other Earth-like worlds orbit nearby stars, and if we could one day reach them. In 2016, that question moved from science fiction to scientific fact, when astronomers at the European Southern Observatory, ESO, announced the discovery of a rocky planet circling Proxima Centauri, the dimmest and closest star in the Alpha Centauri system, a mere 4.22 light-years from Earth. To put that distance in perspective, 1 light-year equals about 9.46 trillion kilometers, even at the speed of our fastest modern spacecraft, traveling 4.22 light-years would take more than 70,000 years. Yet, in the vast scale of the universe, this is our next-door neighbor, the first stop on any interstellar journey humanity might undertake. Proxima Centauri b did not appear by chance. It was found using the radial velocity method, a technique that detects tiny wobbles in a star's motion caused by the gravitational tug of an orbiting planet. The HARPS spectrograph, mounted on the ESO's 3.6-meter telescope in Chile, spent years measuring subtle shifts in Proxima Centauri's light, revealing a planet with a minimum mass of 1.07 times that of Earth, classifying it as a super-Earth, a rocky world, slightly larger and more massive than our home planet. Its radius is estimated at roughly 1.1 times Earth's radius, meaning it has a solid rocky surface, similar to the terrestrial planets in our own solar system, ruling out the gas giant composition that makes many exoplanets uninhabitable. This alone makes Proxima Centauri b a revolutionary find. Most exoplanets we have discovered are either gas giants or frozen worlds, far from their star's habitable zone, but this one checks the first critical box for life as we know it. Let us turn our attention to the planet's orbit, a feature that defines every aspect of its climate and potential habitability. Proxima Centauri b orbits its host star at a distance of just 0.05 astronomical units, AU, about 1/20th the distance between Earth and the Sunday. In our solar system, a planet this close to the Sun would be a scorched, airless rock like Mercury, but Proxima Centauri is no Sunday. It is a cool, dim, M-type red dwarf star, only about 1/7 the size of the Sun, and less than 0.002 times as bright. Because red dwarfs emit far less heat and light, their habitable zones, the narrow regions where liquid water can exist on a planet's surface, lie much closer to the star. Proxima Centauri b sits perfectly within this zone, receiving about 65% of the stellar radiation that Earth gets from the Sun, creating conditions where liquid water could theoretically pool on its surface. Its orbital period is just 11.2 Earth days, meaning a year on Proxima Centauri b lasts less than 2 weeks, a dizzying cycle that shapes every weather pattern and geological process on the planet. But habitability is about far more than just orbital position, and Proxima Centauri b faces unique challenges that test the limits of what we consider a livable world. The most dramatic of these is tidal locking, a gravitational effect caused by the planet's extreme proximity to its star. Just as the Moon is tidally locked to Earth, showing only one face to our planet, Proxima Centauri b is almost certainly locked in a 1-to-1 orbital resonance, meaning one side permanently faces its star in eternal daylight, while the other is trapped in endless freezing night. This creates a planet of extremes. The day side could be baked by constant stellar radiation, with surface temperatures soaring high enough to vaporize water, while the night side would plunge to hundreds of degrees below zero, turning any atmosphere into frozen ice. However, there is a glimmer of hope in the narrow twilight band, known as the terminator, the circular boundary between day and night. Here, temperatures could balance out to mild Earth-like conditions, creating a habitable strip where liquid water, stable atmospheres, and even life could survive. Some climate models suggest that a thick enough atmosphere could circulate heat from the day side to the night side, softening these extremes and making large swaths of the planet potentially livable, a game-changing possibility that keeps astronomers hopeful. Another critical threat to Proxima Centauri b's habitability comes from its temperamental host star. Red dwarfs, like Proxima Centauri, are notoriously active, prone to intense stellar flares and powerful bursts of X-ray and ultraviolet radiation. These flares are far more violent than solar flares on the Sun, releasing enough energy to strip away a planet's atmosphere over millions of years. Proxima Centauri b receives about 400 times more X-ray radiation than Earth does, a relentless bombardment that could erode any protective atmosphere and leave the surface exposed to harmful cosmic rays. For life to exist, the planet would need a strong magnetic field to deflect this radiation, much like Earth's magnetosphere shields us from the sun's solar wind. While we have not yet detected a magnetic field around Proxima Centauri b, its rocky composition and Earth-like mass suggest it could have a molten core capable of generating one another piece of the puzzle we are eager to solve. The discovery of Proxima Centauri b has also redefined humanity's approach to interstellar exploration, turning distant dreams into actionable plans. One of the most ambitious is Breakthrough Starshot, a project backed by Stephen Hawking, Yuri Milner, and Mark Zuckerberg, which aims to send tiny laser-propelled nanocraft to the Alpha Centauri system at 20% the speed of light. These postage stamp-sized probes, equipped with light sails and high-resolution cameras, could reach Proxima Centauri b in just 20 years, sending back the first close-up images of the planet's surface atmosphere and potential oceans. For context, traditional chemical rockets would take over 70,000 years to make the same trip, making Breakthrough Starshot not just a mission, but a revolution in space travel technology. Closer to home, the James Webb Space Telescope, JWST, has already begun studying Proxima Centauri b, using its powerful infrared instruments to analyze the planet's atmosphere for key biosignatures, water vapor, oxygen, methane, and carbon dioxide. These molecules are the building blocks of life as we know it, and their detection would be the strongest evidence yet that Proxima Centauri b could support life. In 2025, JWST captured thermal signals and spectral data from the planet, hinting at the presence of a stable atmosphere and liquid water findings that have electrified the astronomical community. While these results are still being verified, they mark the first time we have gathered concrete data about the atmosphere of the closest habitable exoplanet, bringing us closer than ever to answering the question of whether we are alone. What makes Proxima Centauri b so much more than a scientific curiosity is its role as a bridge between our solar system and the wider cosmos. Before its discovery, we knew of thousands of exoplanets, but most were hundreds or thousands of light years away, too distant to study in detail or consider for future exploration. Proxima Centauri b is different. It is close enough that we can study its atmosphere with current technology, and close enough that future generations could realistically send probes to explore it up close. It is a proof of concept that habitable worlds are not rare distant anomalies, but common neighbors scattered across the Milky Way. It challenges us to rethink our place in the universe, to consider that life might be thriving just a stone's throw away on a world that has been hidden in plain sight for billions of years. We must also remember that Proxima Centauri b is part of a larger stellar family, the Alpha Centauri system, a triple star system made up of Alpha Centauri A, Alpha Centauri b, and Proxima Centauri. This complex gravitational environment adds another layer of mystery to the planet's history and stability. Some models suggest that interactions with the two larger stars could have influenced Proxima Centauri b's orbit, potentially preventing it from being fully tidally locked or creating geological activity that could sustain an atmosphere. This makes the planet not just a single world to study, but a window into the dynamics of multi-star systems, the most common type of stellar system in the Milky Way. As we continue to study Proxima Centauri b, we are not just learning about one planet, we are learning about the conditions that make life possible, about the resilience of rocky worlds in the harshest cosmic environments, and about the limits of human curiosity and innovation. Every new observation, every spectral reading, every computer simulation brings us one step closer to understanding whether this tiny distant world is a barren rock, or a vibrant oasis, a dead planet, or a cradle of life. It reminds us that the universe is not just a vast empty void, but a tapestry of worlds, each with its own story, its own challenges, and its own potential for wonder. For astronomers, engineers, and dreamers alike, Proxima Centauri b is more than a planet. It is a beacon. It is a reminder that the stars are not just distant points of light, but destinations. It is a call to keep looking up, to keep asking questions, and to keep pushing the boundaries of what we can achieve. Whether we find life on Proxima Centauri b or not, its discovery has already changed humanity forever. It has turned the dream of interstellar travel from fantasy into a long-term goal, and it has given us hope that we are not truly alone in this infinite cosmos. As we wrap up this journey to our closest cosmic neighbor, let us carry with us a sense of awe and humility. We live in a universe where habitable worlds orbit nearby stars, where technology can detect tiny wobbles in distant stars, and where human ingenuity can dream up ways to reach for the stars. Proxima Centauri b is just the beginning. In the coming decades, we will discover more nearby habitable planets, develop faster spacecraft, and unlock more secrets of the cosmos. And when we do, we will look back at 2016 as the year we found our first neighbor, the year we took our first step toward a future among the stars. Please like, comment, share, and subscribe to the channel.